Let us start today lenses. Lenses are the optical devices made of transparent medium having curved surfaces. Now here are two types of lenses. One is convex, another is concave. In the convex lens, we can observe the surfaces are in such a way that they are thick in the middle and thin at the edges of lens. Whereas in case of concave lens, the curved surfaces are in such a way that lens is thin in the middle and thick at the periphery or curved surface. Means just outside the lens there is circumference. Circumference is the, we can say, periphery also. Therefore thick at periphery, thin in the middle is a concave lens. Just opposite of it, thick in the middle and thick in the middle and thin at periphery is a convex lens. Manufacturing of lens is shown in the figure. First, for convex lens, there are two circles having center C1 and C2. They are intersecting each other. Then the curved surfaces of the two circles here are making a lens figure, that is, both are convex, biconvex lens, whereas in the other diagram, concave lens, the two circles are not intersecting. They are having a distance between their outer circumferences or periphery, and the figure formed is a concave lens. C1, C2 are the center of curvature, and R1, R2 are the radius of the two circles, are the radius of curvature of the two surfaces also. In between P1 and P2 at the center there is O, means optical center of the lens. Line joining C1, C2 in the extended form makes principal axis. Now we can see the manufacturing of concave lens again. Here there are two centers, center of curvature of the two circles dotted shown in the figure, and the circumference is making a concave lens when there is a distance between the center of curvature more than the sum of the radius of the two circles. Now type of lenses can be extended into various forms also. Converging lenses are the convex lenses we have discussed in the first slide. Diverging lenses are concave lenses we have discussed also in the first slide. Now converging lens or convex lens. Converging means collecting light towards principal axis. That is bending ray of light towards principal axis, converging lens. Diverging means spreading light away from principal axis. Both the lens, after passing light, it is in the diverging form from a concave lens. Now let us come to converging lens. Converging lens, first is convex lens, that is biconvex lens. Both surfaces are convex. Biconvex lens. And then if one surface is in the figure third plane, then word is plane convex lens. Plano convex also. Convex word is showing here that it is thin in the periphery or circumferences, and thick in the middle of the lens. Now there is fourth figure that is showing here. Concavo-convex means last word is convex. Convex meaning is it is thin at the periphery and at the middle of the lens. In this way, first four figures are completed. Let us come to concave diverging lens. In concave lens, here is both surfaces are in such a way that it is thin in the middle and thick at the periphery. If one surface is plane, then this second last figure shows here plano-concave lens. What concave shows here that it is thin in the middle and thick at the periphery or circumference. And last is convexo-concave lens. Concave word is at the last. It shows here it is thin in the middle and thick at the periphery or circumference. In this way, convex lens, concave lens are divided further. Now the image formation by a convex lens when object is at infinity. Rays are coming parallel to each other. If object is placed at infinity, they are falling on the lens, convex lens, and nature of convex lens is converging, means collecting light towards focus or principal axis. Therefore, these rays are going or passing through focus f2 of the convex lens, and they are intersecting at point f2. Therefore, f2 is the image of object placed at infinity. The object is placed at infinity because parallel rays always comes from infinity. Sun may be the example of it. From sun, rays are coming parallel to each other. And if you are placing a lens in front of sunlight and a paper on the focus f2 of lens, then sunlight burns the paper. Therefore, sometimes it is known as burning glass also. That is, paper starts burning because it is a point image and heat is produced as the point which burns the paper. Now let us come to image characteristics, properties of the image. Number one, real. Real image is formed when light rays are intersect actually, means really they are intersecting, both rays are really intersecting, then real image is formed. Inverted, real image is always inverted image. Let us come to the third point, highly diminished. Highly diminished means very, very small. It is just a point image, and this point image is formed on the paper, then the burning glass burns the paper. And finally, the location, it is at focus of lens. Case number 2, object between infinity and 2f. Now, in the case first, we are coming from infinity, and this is now shifting of the object from infinity towards lens. Therefore, object location is between infinity and 2f. As shown in the figure, parallel ray always passes through focus f, and ray passing through optical center comes out without deviation, without bending. This is the property of optical center. Any ray passing through optical center passes without deviation, directly passes. And third one is ray of light is coming from focus f. Then after passing through a lens, it becomes parallel to the principal axis. This diagram shows the three rules of image formation. That is, first rule, parallel ray coming from object passes through focus. Second, ray coming through optical center, middle point of the lens is here, passes without deviation. And rule number third, ray coming from focus becomes parallel after passing through a lens. In this way, all the three red color rays intersect at a point, and that is the head or tip of the image, and this image line is always at 90 degree to the principal axis in the diagram, that is perpendicular to the principal axis. Now come to the image characteristics, that is property of the images. Number one, real. Real means rays of light intersect actually. Light is coming in the other side of lens. Real images are always inverted. Third one is diminished image. Diminished means smaller size image in comparison to object size. And fourth one is location. Location of the image is between f and 2f, that is second focus or principle of focus f and 2f. In between there is location of the image. Next case, object at 2f. When the object is placed at 2f, shown here AB object. Let us start first rule. Parallel ray coming from the object and A passes through focus f2, and another ray coming or passing through optical center passes without deviation, without bending. It is passing in a straight line, and these both rays are intersecting at point A dash. Therefore, we draw a line parallel to the y-axis, and this A dash B dash form the image. Now characteristics of the image. Number one, real. Light is coming actually. Intersection of the light rays is really, therefore real image. Real image are always inverted. And here is similar size image. Length of object AB is equal to length of image A dash B dash. And location at 2f. Object is at 2f and image is at 2f. Similar size. Now bring the object closer to the lens. That is location of object is between f and 2f. Again, rule number one, parallel ray passes through focus f, and second ray is passing through optical center without deviation. These two rays intersect at point A dash, and A dash B dash is the image form of the object AB placed between 2f and f. Characteristics of image, real image, because light is coming in other side. Real intersection of the two rays makes the real image. Real images are always inverted. Third one is magnified or enlarged, means more in length, more in size also, in comparison to AB object. And the last is location of image. It is between 2f and infinity. Now object at focus f. Parallel ray passes through focus after passing through a lens, and another ray is passing through optical center. These both rays are parallel to each other, and parallel rays always intersect at infinity. This is assumed. Therefore, image is formed at infinity. And characteristics of the image, real. Real means really, intersection of light rays are coming really. Inverted image, real images are always inverted. Highly magnified, larger in size, and location at infinity. Below this diagram, there is another diagram at which point object is placed at focus F, and the rays after passing through the lens becomes parallel because parallel lines always meet at infinity, and this may be considered also. Now, next object is between focus and optical center. Object is between O and F1. First focus F1, second focus F2 is shown in the figure. O and F1. Here is virtual erect and magnified image is formed behind the lens, that is in the side of object. Characteristics of the image: virtual means not real. Real light is not intersecting there, therefore dotted rays, and image is also dotted. All the two rays and image also dotted. Virtual always erect, just like real images are always inverted. Similarly, virtual images are always erect images. Next, third point, magnified image, larger in size, and this is also known as magnifying glass. If you are using magnifying glass in the electronics shop and share market, then there is a convex lens and object is placed between lens and focus. Then latter are bigger in size and there is magnification of the object observed in the lens. Location is behind object. In the size it is larger but behind the object, and in the side of lens both object and image are formed. Now convex lens, all cases at a glance means at a time, and we can have this figure also for further discussion. Let us come to convex lens images. There is a table, and in the table these are the various positions of object as well as position of image with the nature of image. Sometimes this is a table and it is coming in the examination to fill up the blank. Object is between lens and focus. Then where is the image formed? What is the nature of image? This type of questions are coming. For this purpose, we have discussion of this tabular form here. Now in case of object at focus, image is real, nature of image real, inverted, highly magnified, and here it is at infinity. This type of tabular form is also valuable for examination purpose. Now come to the uses of convex lens in daily life. Convex lenses are used in microscope in biology lab, and we are using in telescopes also. Telescope to observe the moon during lunar eclipse, solar eclipse also, and in camera lenses for photography, projectors also, magnifying glasses at the shops of electronics to read the letter in the magnified images, and in share market to read the very small letter which is used. And last, we are having another telescope here. Now concave lens. A concave lens, the second figure is showing that it is thin in between and thick at the periphery, and there is image formed also. Rays are coming parallel rays are coming from infinity. This concave lens is diverging, means spreading rays of light. Therefore rays of light are spreading, and in the backward direction they are intersecting virtually, means not really, and making the image at focus. Now let us discuss here two cases. First case is object at infinity. Parallel rays are falling on a thin concave lens and parallel rays are coming from infinity. These rays are diverging. Therefore, in the forward direction, they are not intersecting, but in the backward direction, they are intersecting at focus. In parallel rays means object at infinity, image is at focus. Now, the length between optical center, midpoint of lens, and focus is known as focal length. Image characteristics, property of the images. Number one, virtual. Virtual means light is not really approaching. That is, two rays of light are not really intersecting. Therefore, image is virtual image, but it is observed by the observer. Virtual image, second is erect. Virtual images are always erect. That is, in the similar side there is head and similar side there is foot of the object. Diminished means smaller in size, location at the focus in the side of object. Both are in similar side, object is also, and image is found in the similar side. Now, the remaining other cases, just like we are having 6 cases in a convex lens, here there are first case for object at infinity and remaining 5 cases are making similar type of image, similar type of diagram. Therefore, this case object is between infinity and optical center of lens covers the remaining 5 cases we have discussed in various locations in the convex lens. Therefore, all the remaining 5 cases are considered in a single diagram when object is placed in front of a convex, a concave lens here, not convex. Convex we have discussed earlier. Now let us come to the discussion. Object is placed between f1 and 2f1 and here is we are observing parallel line is diverging, another is passing through optical center and both are intersecting making the image. Actually, we have focus, principal focus f2 in left hand side, that is toward object in case of concave lens, whereas in the case of convex lens this principal focus is in the right hand side of the lens. This is the basic difference for the location of principal focus. Therefore, in the figure it is written left hand side, we can see 2f2 for the image and image size, yes, and 2f2 also in the behind the object. Location of image here is in between focus and lens. Now let us come to image characteristics, properties of the image. Virtual image. Virtual means rays of light are not really intersecting. One light ray may be really coming to it, another is not coming, that is virtual. Then image is always virtual. Number 2, erect. Virtual images are always erect. Diminished, smaller in size, location between focus F and optical centers or lens. Usage of concave lenses, binoculars, telescope. Cassegrain telescope is one of the type of telescope in the class 12. Eyeglasses for correction of myopia and flash glass. Let us come to differences between convex lens and concave lens. Convex lens, first difference, it is converging, collecting light towards principal focus. Diverging. Concave is diverging means spreading light. We have seen in the searchlight also. Second, convex lens is thicker at the center and thin at the edges. Concave lens, second point is it is thicker at the edges and thin at the center of lens. Point number 3, convex lens, its principal focus is real. Principal focus is f2. If rays are coming from infinity after passing through a lens, they meet really in case of convex lens, and that point is f2. We have discussed f2 also, whereas in case of concave lens, point number 3, its principal focus is virtual, that is, it is towards the side of object. Virtual means rays of light are not approaching to it, therefore in the backward direction it is formed because rays of light are diverging after passing through a concave lens. Fourth point, its focal length is positive, and fourth point in concave lens, focal length is negative. Say focal length of convex lens is 10 centimeter, then for convex lens we are using a numerical f is equal to 10 centimeter with positive sign, whereas in a concave lens it is minus 10 centimeter. And fifth point, it can be used for correction of hypermetropia. Convex lens is used by the old age person who are more than 50 years generally, and they are unable to read newspapers. Therefore, they are using here convex lens for magnifying the size of letters. In case of um, children, let us come to concave lens. Children in the classrooms we have seen between the age of 10 to 25. They are unable to see the far object, that is, they are able to read books and notebooks without their specs, but they are unable to see the board, classroom board in the class clearly. Therefore, they are suffering from the defect myopia, and for correction of myopia, concave lens is used. Here is the sign convention in numericals, as it is similar to the sign convention in mathematics. Positive x-axis, negative x-axis, positive y-axis, negative y-axis. No change. When we are discussing sign convention, lens is always kept at the origin of coordinate axis. We have shown just before it. 0, 0 is the origin, and all the distances are measured from the origin. Object is placed in the left hand side, therefore distance of object in the left hand side of the lens is negative, and image is shown here in the right hand side. This distance is positive. Now the length of object AB is positive because it is in positive x-axis, and image length A dash B dash is negative because it is considered in the negative side of y-axis. Now these are the again two lenses. One is convex lens using as a magnifier or simple microscope on the left hand diagram, and this burns the paper also. If we are placing the lens in front of sun, then after converging light, the paper is placed on focus of this lens, starts burning. If you are keeping this convex lens on the paper or notebook and see the size of letter, then on moving this lens in upward direction, size of letters increases. Therefore, it is used as a magnifier or magnifying glass or simple microscope. And second side, second diagram shows here concave lens, diverging lenses. They are spreading light. They are used in searchlight, and these lenses are diverging nature.